Hello guys. So today it's all about TensorFlow Tensorboard and visualizing your input data on a high dimensional space. So it really looks beautiful. This is a projection of your MNIST dataset on a 3D space. So as you know, MNIST has 784 pixels, so it's a 784 dimensional feature space which has been reduced by TSNE and even PCA. You can visualize here. But TSNE gives a cooler representation. You can see how all different digits have clustered together and they are separate from each space. And to make it cooler, let me enter this night mode, and you can see this is pretty cool now. So you can see all the numbers, they're separate from each other, and they have made a clusters, and you can see individual clusters by typing here number 6. So these are all the 6 gathered up here. Let me go to the day mode. So you can see, and if you type 0, so all the zeros have clustered over here in the top region. So if you go for a 9 maybe, so 9 have clustered over here, or 4s have clustered over here. So you can see it's pretty cool. So and obviously you can refresh from home, and you can zoom in and zoom out to the data. You can you can rotate it wherever you want. You can zoom it with your center mouse button. You can zoom in. You can see you can go to the particular region. 1, this is 8, this is 7. So this is really cool stuff. We can go to home. So yeah, you see, pretty cool. Okay, so this video will try to go from this block of code to this TensorBoard visualization, this embedding visualization. So let's start how we can go from this code to this cool diagram. Okay, so let me open my Spider environment, and all you need is this 25 to 30 lines of code. That's all. Okay, cool. So this is pretty simple. So you have to import all the TensorBoard libraries which they have provided, and then you have to provide a log directory where all your logs about the data, or even if you run the code, where it will be stored. So I have created in my home path, and I have added directory MNIST TensorFlow log1. So it's already there. I have trained it, but let me retrain it for you now. Let me give a new directory log2, and yeah, there is no directory log2 here, so let me create one quickly. And yeah, so MNIST Tensorboard, yeah, let me make a folder log2. That's all. Okay, so and in order to actually visualize the this visualization embedding in a better way, like we need to assign labels to different data points. So for that we create a metadata.tsv file, and it will be in my log2 directory. So this code does that, and then you can see now the log2 is empty, but once I run the code, you get like this, like the log1. So yeah, you see it's empty. So and then we'll define a MNIST image, which will be your test image. It will be your operator called variable, and it will be a variable operator called images. And then we'll open the metadata, and for 10,000 test example, we'll describe the format in which it will be saved in metadata.tsv. And then obviously we'll start the session and we'll save it in our log directory. So that's pretty simple, and let's run this code. So okay, and this is where your input data will be loaded. If it's already there, it will extract it. If it is not there, it will download it. So it's extracting for me because the data is already. So you saw, so like the log2 directory was empty, but now we get all these informations that we are going to use for plotting our TensorBoard. Okay, so let me stop this my TensorBoard from here, my prompt. Let me do Control C, and it stopped. Now how you can run your TensorBoard? So well, it's pretty simple. So you can see the log directory for me is my path, which was D drive, and this MNIST TensorBoard log2 path. So you have to go to that particular drive, and then you have to just write TensorBoard, then give the log directory. Where exactly is my log directory? It's in my technical works, in my tensor TensorFlow, and it's in my MNIST Tensorboard, and it's in my log 2, if you remember. And then I have give a port. Even if you don't give it, it's no issue, because default it takes the port as 6006. So now you can see I have stopped this, and if I refresh this, you can get nothing because it's nothing there. So let me just close it, and let's go here and let's run this TensorBoard. Okay, so what's the issue here? Yeah, so once you run your TensorBoard, you will get what to say, a prompt of this, that it started on port 606 and this IP, but if you go to this IP, you won't connect it. You have to just do a simple stuff. You go to your browser, just type local host colon and 6006, and this will run your TensorBoard for you. So I have only in this code, if you see, I have only given the command and save in the log directory only the embedding visualizer. I haven't saved any of the like graphs or histograms or any other things. So only we directly go to the embedding, so it will start loading your metadata, and first by default it takes your PCA, so it applies a PCA dimensionality reduction and project. You have 10,000 test images. Dimension is 784, obviously, because there are 28 cross 28 pixels. Each pixel is a feature space. Each pixel is a feature, so we get a 784 feature space. So this is without color map. We have 10 labels, so we can assign 10 color maps, and then obviously we can assign the labels to them. So you can see the numbers appearing. If I zoom it, maybe you can see it. You see the numbers. Okay, we go to home. So this is pretty cool, but the coolest one is the TSNE. So you just click here, and it will take some time to run it, but it's all worth it. You get, at the end of the day, you get to this cool picture, so it has some parameters like perplexity, learning rate, that by default it sets it here. You can even change it. There is a how to use TSNA effectively. You can go there and learn more about perplexity and learning rate. So it's finding nearest neighbor till it reaches 100%. Will take some time to load, but it's a pretty cool stuff, and you can use it for like visualizing your input data also before training algorithms. See how the features are on a high dimensional feature space. And yeah, so 92, 95, 97, and it starts TSNE at a count of 3, 2, 1, go. So it will run for some iteration. I will when it runs, actually it tries to clusters between each data, like we have 10 different types of data from 0 to 9. So within each data it will try to form some cluster, and how it's doing it, I have not much idea. You have to go to the TSNE. So it will take some time to cluster. I will run it for around some 1000 iteration. So I will pause it for a while. I'll come back after 1000 iteration. So there guys, there it is. After around some 1037 iteration, I stopped it, and you can see how beautifully all the data points have clustered in the group. So you can see all the 6 here, all the 4 here, and obviously you can search here and see. So all the 6, you see they have clustered here. There are fews here and there, but that's okay. All the 9s, they have clustered over there, and I don't know why that shape. Actually, you have to run the TSNE maybe. And then if you go for a 0, they have clustered very beautifully over here. If you go for a 2, okay, they have clustered down. For a 5, so they have clustered here, and you can look for yourself. So this is pretty cool stuff, and always you can go to this home stuff, and it will kind of reset the display. And this one I showed you, it's getting the label. So if you uncheck this, then you will get unlabeled data without the label number, and if you check it, you will get their labels. So that's what in metadata, if you even if you want to like visualize your data, we have to create a metadata with the label names. And then this is the night mode. It's very cool stuff. Wow, this looks really cool. So yeah, you can see the data floating there. And another feature is selecting a specific region. So I select this region around 195 points, and I can see how this 195 points are. And this is in the PSNE, and if I do TSNE, then it will again start the iteration stuff. So I'll stop it for a while. Okay, let me go to show all data. Let me go to home. Let me go to TSNE and home and click here. Yeah, so I get my cool stuff. Okay, and yeah, this is the label as I showed you. You can go to no color, you can go to label, and yeah, so pretty much that's all for embedding, I guess. In the screen, you can see, and you can click on any points. Like I clicked on label 1, and it will show you 101 nearest points, and it's a cosine distance. There is option for Euclidean distance also, and it will show you to that particular clicked one. It's 101 nearest neighbors, and they all are one in this case. So if you click somewhere here, 3, so they are all 3 because they have clustered out so nicely here. Okay, so yeah, that's all. You can run this, and it's pretty cool stuff. And the code, this block of code, I'll put it in the link below, and you can try it out and play and enjoy with the Tensorboard. It's really cool stuff. Okay, good luck trying it out then. Bye bye.